Alright, today we're going to be talking about radicals. Now, radicals are, they can be complicated. They start out very, very easy. So let's just go ahead and dive right into these things. They're really not that bad starting out. Um, we got a lot of basics we've got to cover first. So we'll take a look here. First thing we're going to look at is that this problem right here, and if you're following along in your packet, this is problem number 1 on page 1. Square root of 25. This is a radical. Now, this sign right here is called our radical sign, is also known as the square root sign. You'll hear us say that a lot in class. So either square root sign or radical sign, they're the same thing. The number underneath the radical sign is called the radicand. And you need to know that for when you get to your testing. They may ask you what the radicand is in a problem, and just know that that is the number that's underneath the square root or the radical sign. So in this case, the radicand would be 25. Now what we're going to do is we're simply going to take the square root of 25. And when we're looking for the square root, you've all done this in your calculator, all we're really doing is trying to find a number that multiplies times itself to give us this radicand, this number underneath the radical sign. So, I mean, you've done square roots for several years now. This one should be very, very easy. This is a perfect square. So we know that 5 times 5 gives me 25. And so if I took the square root of 25, my answer is going to simply be a 5. Nothing much to that. That's a very easy problem. All right. Well, let's add a little bit more to it. And that's what we're going to do with all these. We're just going to keep adding a little bit more at a time every single problem. So what if we had the square root of 40 plus 9? And again, I'm following along right through your packet here, so this is just number 2 in your packet. What you'll want to do in this case, since everything is underneath that radical sign, see how the top of this extends all the way out past that 9. So all these numbers are underneath the radical sign. Since they are underneath this, we can add these two together. So 40 plus 9 is 49, so we're going to rewrite it like this, the square root of 49. And I know, again, this is a very basic problem. The square root of 49 is simply 7, because 7 times 7 gives me 49. Again, we're looking for numbers that multiply times themselves to give me the number underneath the radical. Okay. Well, let's look at number 3 here. I'm going to draw this one down here. So we have the square root of 20 minus 4. So again, everything is underneath the radical sign. So it's not like this. Let me show you an example of what I mean. If it looked like this right here, so you didn't have that radical sign extending all the way out, you couldn't do anything with it. But the radical sign in this case extends all the way out past the 4. So since both of these numbers are underneath the radical sign, you can go ahead and simplify this. So 20 minus 4 gives me the square root of 16. Square root of 16 is 4. And again, so far these are easy because we're working with perfect squares, and we'll get to what to do with other types of problems here in just a little bit. Now we're going to do numbers 4 and 5 next, and these are done very similarly, except that now we're dealing with variables. And all you're going to do right here, this is actually not a very hard concept. When you're taking the square root of a number, you're looking for something that is multiplied times itself to give you that number. So earlier we did the square root of 25, and we found that 5 times 5 gives me 25. Well, now with variables, we've got to find something that will multiply times itself to give me this number right here. And if you remember with exponents and variables, when you are multiplying, you're actually adding. So what we want to do is actually divide this exponent by 2, because we're looking for 2 numbers that multiply to give me this right here. So you could factor this down to x squared times x squared, because exponent of 2 times exponent of 2 gives me an exponent of 4. So just divide the exponent by 2, and that'll give you the square root of it. So your square root of x to the 4th is just simply going to be x squared. Just like that right there, okay? Now, if we look at number 5, we have 2 different variables in here we've got to work with. So let's start with the x. Now, remember, on our last problem, all we do is to take the exponent and divide it by 2. So what is 2 divided by 2? That's going to leave me with simply x. And what is 10 divided by 2? Well, 10 divided by 2 is 5, so that means my square root of this entire thing is going to be x y to the 5th, because all I did was I divided each of these by 2. I'll just write that in real quick. So divide by 2 and divide by 2, and that's where I got my final answer right here for number 5. So all you're doing if you have an exponent, if it's an even exponent anyways, with the square root symbol, all you're doing is simply dividing that number by 2 and then writing out the variable with whatever your answer was there. So 4 divided by 2 gave me 2. 10 divided by 2 gave me 5. 2 divided by 2 gave me... And it's understood there's a 1 right there. You don't have to write that in, but you can if you want to. It's not going to be wrong if you don't. Now my next two numbers, number 6 and 7, we're going to kind of combine a few things. We're on number 6 here, we're going to combine having regular numbers and variables with exponents, and we have to take the square root of this. So let's just combine what we've learned so far on these first 5 problems to get my answer on this one. So let's look at the number first. What is the square root of 4? And that's an easy one. That's a perfect square. We know the answer is going to be 2. Well, now let's look and see what is the square root of x to the 18th. And if you remember from the last problem, all you have to do is divide that exponent, if it's even, by 2. So 18 divided by 2 leaves me with 9. So my answer is going to be this, 2x to the 9th, because 2 is the square root of 4. X to the 9th is the square root of x to the 18th. Now if we go over to number 7 here, we've got an expression underneath the radical sign here, so we've got to work out that expression first. So you can put everything in the calculator that is underneath the radical sign here. So if you wanted to put that, just all the stuff that's inside these two green parentheses, you could put that in the calculator straight as is, and it's going to give you an answer. Or you can multiply it out by hand. It doesn't really matter. That's what I'm going to do. So 3 squared is going to give me 9, plus 4 squared is going to give me 16. And remember, we're just going to bring that square root symbol down because we haven't done anything with it. Now, this looks more like number 2 now, where all we have to do is just combine these two numbers. So 9 plus 16 gives me the square root of 25. And then from here, it's a nice easy problem. Square root of 25 is simply 5. Now with our next two problems, what we're going to do is we have actually a division problem all underneath the radical sign. The first thing you want to do with a division problem is you want to see if the numerator can be evenly divided by the denominator. So if we did 72 divided by 2, what are we going to get? Put that in your calculator and you're going to get 36. And then now you can see you have the square root of 36, which is just 6. So that's a pretty easy problem right there. It really isn't that difficult. Now we'll come back to them later here in just a little bit actually on what to do if these two numbers do not divide evenly. But we'll come back to that in a little bit. Well, let's look at this next one here. This is number 9 in your packet on page 1. So if you take 75 and divide it by 3, what are you going to be left with? You're going to be left with 25. And then you have your m's. Now remember, rules of exponents. When you're dividing exponents that have a similar base, what are you really doing with those exponents? You're subtracting them. So m to the 5th divided by m to the 1st is going to leave me with m to the 4th. Are we done yet? No. Why are we not done? Because this is not simplified as far as it can go. So you always have to see, is there anything else that I can simplify on these problems? Well, let's take our original number here, 25. And so the square root of 25 is going to be 5. M to the 4th, to get the square root of that, we just simply divide the 4 by 2. Remember that from our earlier problem, so divide that by 2. And that's going to leave me with m squared. So 5m squared is that completely simplified. Now we're looking at numbers 10 and 11 here in your packet. And what we'll do here is, if we look at number 10, we want to simplify this underneath the radical because we got this division sign. We want to simplify that as far as we can go. So let's look at these numbers. 18 divides by 2 evenly, I know that. So I'm going to draw the radical sign. So 18 divided by 2 gives me 9. A to the ninth divided by a to the third. Remember, we subtract our exponents, so 9 minus 3 gives me a to the sixth. And then b to the fifth over b to the first is going to give me b to the fourth power, because again, we're just subtracting those exponents. Now we have a simple problem. All we have to do is take the square root of these numbers. Square root of 9 gives me 3. Square root of a to the sixth, remember, divide it by 2, so that's going to give me a to the third. And then the square root of b to the fourth, divide that number by 2, that's going to give me b squared. So that's all we have there. That is our final answer on number 10. Now, number 11 looks kind of confusing, because at first thought, because earlier I'd said we're going to deal with some that don't divide evenly. Well, if you put 2 divided by 72 in your calculator, it doesn't divide evenly. You're going to get a decimal number. But what we can do is we can reduce the fraction. So let's start by doing that, okay? So I'm going to redraw my square root symbol here. 2 divided by 72. There's a couple ways you can do this. If you put it in your calculator, in your TI-83 calculator, and hit math, enter, enter, it's going to give you a fraction, a reduced fraction, every single time. We could also simply divide 2 into both of these numbers, and that'll give me my lower fraction. Either way you do it, you're going to get 1 over 36, okay? So this is the reduced fraction. From here, what you want to do is you want to split this up into 2 different radical signs. Take the numerator and put it on top here with the 1, and the denominator has the square root of 36. So you're going to have 2 different square roots, one on the top, one on the bottom. What is the square root of 1? Well, 1 times 1 gives me 1, so my answer is 1. What's the square root of 36? 6. So that will reduce down to 1 over 6. Now my next problem is the square root of x minus 2 squared. It looks kind of confusing, but there are a couple of ways you can look at this. I'm actually going to draw this problem out twice just so we have the 2 different ways to look at it. The first way is the way that I think is the easiest, and it might not be for you, but I think it is. What I simply do, anytime I see a square root symbol, the radical sign, and then underneath that square root symbol I see a square, the little number 2 right here, I know immediately that those 2 are going to cancel out. They're opposite functions. It's kind of like if you had positive 5 and negative 5. When you subtract those together, they're going to cancel out. And so the same thing here. These are the opposites. So the square root sign cancels out, and the little 2, the squared, cancels out. So that leaves me with x minus 2. You can always do that. So even if you had something like this, the square root of x squared, well, again, the square root sign is going to cancel out. My 2 is going to cancel out. That's going to leave me with x. So you can do that every single time. That's how I like to do it. The other way to look at this is this way right here. We're looking for a number that multiplies together to give me this right here. And it has to be multiplied by itself. So really what this is saying with that squared is that we've got x minus 2 times x minus 2. It's this and this are the exact same thing, okay? So to take the square root of this, all we have to do is just simply take one of these and cancel it out, just like that right there. So my answer is going to be x minus 2. Because again, it's just like earlier when we had the square root of 25. We found that 5 times 5 gave me 25, so my answer was 5. Same thing here, x minus 2 times x minus 2. If you take the square root of that, it's just going to be one of those, x minus 2. Either way you do this works. I like this way because it's quicker for me, but it's really your choice. Now on number 13, we have a trinomial underneath the radical sign. And so what we've got to do first is factor this trinomial out. So what am I going to do? I'm going to come down here and I'm going to go ahead and draw out my radical sign. But above that, I'm going to put my two sets of parentheses and solve this one just like we've done before with factoring trinomials. X squared is in the front, so I'm going to put x here and x here. Now I've got to find a number that multiplies together to give me 16 and also adds together to give me 8. And we can go through all the factors of 16. I'm going to do this really quickly though. 4 times 4 gives me 16. 4 plus 4 gives me 8. This sign right here tells me that both of my signs are the same. This sign right here tells me that they are positive. So that's what we have factored out. So we have the square root of x plus 4 times x plus 4. And then you can clearly see what we're going to do from here. We simply cancel out one of those x plus 4's with that square root sign. So that's going to leave me with simply x plus 4. And I'm going to skip number 14 because it's pretty much the exact same thing. All you have to do is factor out that trinomial and then take the square root of it, which is very easy.